The insane engineering of SpaceX Raptor engines. Hey guys, welcome back to our channel. Today we will talk about the insane engineering of SpaceX Raptor engines. Here we begin. The new Raptor engine of SpaceX is a methane engine that is fueled to full flow, stage combustion cycle engine, and is hard to develop. Now this topic may be really intimidating, so that we can put Raptor's engine in the context of the current workhorse of SpaceX, the Merlin, the Space Shuttle RS-25, and the RD-180 engines, as well as the BE-4 and the F-1 engines. We will then compare the Raptor with a few other common types of rocket engine cycles. And then, if this is not enough, SpaceX not only uses a Crady motorcycle, they will also use liquid methane as fuel, other thing no orbital rocket has ever used. Basically, rockets are just propellants with some skin around them to maintain it, and they've got something on the back that can really throw the propellant quickly. And the quicker you can throw that fuel, the better to simplify it. The easiest way is to save all the thrusters in your tanks under real high pressure and place the valve on the end of the tank and the propellant dust that accelerates the thruster into a functioning thrust. Done. Don't open a valve with insane pumps or complicated systems, let it rip. It is known as pressurized rocket motor, and several main types of engines are used: cold, gas, monoprop, and bipropellant pressure fuel motors. They are often used for reaction management systems because they are simple, reliable, and fast. But pressurized motors have a significant factor: the pressure flows from high to low so that the motor cannot be higher than the propellant takes. Therefore, your tanks will have to be stronger and thicker and heavier to store the fuel under high pressure. Look at the vessel or COP fees with the composite overwrappings. They can store gas nearly up to 10,000 psi or about 700 bar. However, the amount of fuel and pressure which can be stored remains limited, so when you attempt to provide a payload to orbit, this does not go very well. So intelligent rocket scientists quickly realized that it is one thing that they could do to make the rocket as light as possible. Enhance enthalpy, that'd be an excellent name for a 90s metal band. The internet is welcome. The relation between volume, pressure, and temperature is essentially enthalpy. Therefore, higher pressure and temperature in the combustion chamber correspond to higher efficiency, and more rocket engine mass the more powerful. So, you could either increase the pressure in the tanks and shoot the fuel into combustion chamber with a high power pump to shoot more propellants into the motor. It sounds like an idea for the second option. However, pumps requires a lot of energy to move hundreds of liters of fuel per second. So what if you look at a tiny rocket engine and aimed it right at the turbine and spin it up fast? You could exchange some of the rocket fuel's chemical energy for kinetic energy, which can be used to spin these powerful pumps. The end venue is the combustion cycle with turbo pumps, but there are still certain limiting factors such as how high pressure always wants to be low and how heat is used to melting things. So all these factors must be monitored while you try to squeeze any power out of your engine. We can talk here about many cycles, but we'll stick to 3 of the most common cycles, or at least 3 of the most important ones when placing the Raptor in context. We have the gas generator cycle, the combustion part of the flow, and finally, the combustion cycle in full flow. And maybe in the following paper, I'll try to complete a full rundown of all fluid-driven rocket motors, including a new fun alternative such as electric pump-fed motors on the Electron rocket of Rocket Lab. Recall, the pressure always flows from high to low, so the turbo pumps have to be higher than the chamber's pressure. This means that the inlet into the burner is actually the highest pressure point in the whole rocket engine. Why is it soothing in comparison to the main combustion chamber that leaves almost no visible exhaust? Well, because rocket drivers can get super hot, like thousands of degrees Celsius. Then they need to ensure that the temperature isn't so warm that the turbine melts. The whole turbo pump mount is cool enough to keep operating continuously. The most efficient and most energy efficient running with the perfect fuel-oxygen ratio and the crazy amount of heat. You can operate the pre-burner with an optimal ratio to keep temperatures low, either as too much fuel as an oxidizer or too high oxygen. So if you run fuel-rich engine RP1, you will see some unburned fuel appear in the dark suit clouds. Unbranded carbon molecules highly pressurized bind and form polymers, known as coking. The sucker begins to stick to all of its touches and can block injections or even damage the turbine. You don't simply use fuel in some oxidizer with the closed cycle engine and burn that, you shoot all the wealthy propellant through the turbine at the pre-burner to spin the curved side. So the total oxygen passes through the pre-burner in an oxygen-rich cycle, and the amount of fuel goes to the pre-burner. You need only enough to provide the turbine with the right energy to spin the pumps quickly enough to pressure the pre-burner combustion chamber to make the right power to space This brings us to the end of our video. I hope you enjoyed it. Hit like if you did, and don't forget to subscribe to our channel so you never miss out on any of our videos. Also, watch the next 2 videos that are on your screen because I'm sure you'll love them. With that, I'll see you in the next video.